Hi everyone, this is the virtual poster I presented at the STAN conference yesterday. I thought I should make a video for people that were not able to attend. So this is research that I did with my former colleagues Jesse Chandler and Daniel Tao from Mathematica. In this presentation, I'm going to be speaking on my own behalf and not on the behalf of Google or Alphabet. So with that out of the way, let me tell you the title of the paper we wrote is Asking One Question and Answering Another when Decision and Statistical Analysis are not aligned. For motivation and related literature that I highly recommend you reading, I want to start with this paper that Mansky wrote, The Lure of Incredible Certitude. So basically, this is a critique about how some researcher presents the results. They basically focus on the point estimate and say, yeah, my audience cannot handle uncertainty. And he argues that that's actually harmful, not only for the people they're trying to help, but for like the trust that people have on science in general. Similarly, another relevant paper is the statement that the American Statistical Association did a while back, saying that sadly most people don't understand p-values, so you should stop using them. And they recommend a couple of different things. One of the things they recommend is using Bayesian. The other thing they recommend is using confidence intervals. So related to this, there is this paper that talks about the null ritual and how people like blindly basically run always the same analysis where they say, okay, I'm going to run something and I'm going to say 0 is the relevant threshold, and is this thing statistically significant with a 95% confidence interval? So it's like the interval touching 0 or not, and that's basically it. That is bad because first, 0 may not be the relevant cutoff for making decisions, and also some people may want more than a 95% certainty for their decision, or some people may be more comfortable making decisions with less certainty instead of you telling them, I cannot reject the null, that this is not different than 0. So one more paper I recommend you reading is this paper by David Romer, praising confidence interval and saying how that is what we should be using. So let me go back to what we did. So what we did is a very simple experiment using a convenient sample with Amazon Mechanical Turk. And if you want to know more about the sample, I will send you to the paper. Right here, I'm just going to tell you we did our due diligence. We asked people questions to make sure that they were paying attention. We are only using people that have good reputation on Mechanical Turk, etc. So what is the experiment? We basically create this synthetic data and create, based on that synthetic data where we know what the truth is, different reports. And in these different reports, we analyze this data using a Bayesian methodology or a frequentist methodology, and we present the results in different ways. So basically, we are going to assign people to two different reports that they're going to have to give a recommendation about whether or not to adopt a fictional after-school program based on what they read. So basically, everyone is going to see some common text saying that you are the curriculum coordinator in a school district, and it's a small school district with just 20 schools. You have to decide whether or not the school program should be adopted. So the school district for which you are working is considering an after-school program that is somewhat expensive, and the school board thinks that it's only worth adopting if this after-school program is going to improve student achievement on average by at least zero point 0.2 standard deviations. So here is the first thing you should notice. For this particular school district, 0 is not the real relevant cutoff for making decisions. So you are also told that a neighboring school district published a report describing what they found from their small pilot testing the same after-school program. And you basically had to read that report and make a recommendation. So one of the ways we present the findings is with this Bayesian methodology, in which we define a region of practical equivalence using this point 2. So using that, we basically show you this interactive visualization and this text, and the visualization basically says that there is a 72% probability that the intervention is for all practical purposes equivalent to 0, so to the status quo. And there is a 28% probability that the intervention improves student achievement by at least zero 0.2 standard deviations. So with this interactive visualization, you can play, you can look at the whole distribution. So here is the cutoff of zero 0.2. You can look at the prior that the neighboring school district had when they ran this analysis. So when they ran this analysis, basically before looking at the data, they say, okay, there is a 42% chance that this is worse, a 16 that is equivalent, and a 42 that is actually better. And you can see after they run the analysis, they update their beliefs and they think it's most likely that it's equivalent to the status quo. Similarly, there is a Bayesian analysis in which the neighboring school district used 0 as their cutoff for making decisions. So basically, they find that there is a 98% probability that intervention has a positive effect. And you can look at the posterior. It's the same posterior. The only difference is that there is not a region of practical equivalence. There's just a 0 for the cutoff. And you can look at the prior, and it's exactly the same prior. It's a 50% that is worse, a 50% that is better. The other way we present the results to people is with the frequentist, most traditional way of presenting results, as the point estimate and the confidence interval that people like to praise these days. So finally, we also presented results using a frequentist equivalence testing toast and with this visualization. So what do we found just to go to the point? We're able to replicate results from our previous study. So we find that people are more likely to recommend switching to the new program when presented with the Bayesian analysis with an MME equal to 0. So that will be this one. Compared to the frequentist analysis, that is 84% versus 61% of the people are recommending switching to this new after-school program. So then we have something new in this paper is comparing the Bayesian presentation that includes an MME of 0.2. Only 42% of the people recommend switching versus 57% of the people when presented with the frequentist version of this analysis. And I'm just showing you raw data because these effects are so large that you don't need any fancy statistics. In the paper, we go over the fancy statistics. So finally, what about confidence? We again replicate results from our previous study, and we find that people are way more confident when we present results like this than when we present results like this about the decision they're making. And finally, if you use the frequentist version of equivalence in testing, we estimate that it's a 70% probability that this framing is going to lower confidence by at least 5 percentage points compared to the Bayesian using the rope. So that's basically the gist of the paper. It's a very simple experiment that I think has some important insights. So don't just follow the null hypothesis ritual. Talk to the people you are trying to help before you do any analysis to figure out what are the decisions that they're trying to make. And basically the exercise I like to do is like if you could ask an oracle one question, and that question is, will this new thing improve the outcome that I care about by at least X? What is that X for you? So that is the minimum meaningful effect. In some cases, that may be 0, but in some cases not. So you should know that, and you should present results in a way that takes that into consideration instead of just presenting just a point estimate or a point estimate with a confidence interval. So finally, something that I would like to see in the future is more research presented using this like multiverse analysis interactive document type. So here you can see basically you can play with the document and change the prior and the results change live. Sadly, right now it's complicated to produce these documents. Another thing, if you're a frequentist and you are not ready to become Bayesian, you may want to read this paper. So this paper basically ran an experiment showing different ways of presenting frequentist findings and how that affects what people choose. And that's basically it. If you like this visualization, I have a GitHub repo with an early prototype of an R package that basically allows you to create this visualization very easily. There is a lot of work to be done there, so if you want to help with that, that's also welcome. So that's all. Thank you. Bye.